Welcome to this video on the optional method on load calculations. We're going to open our codebook and go to article 220.80, which is also article 220 part 4. We'll see it says part 4 optional feeder and service load calculations. So we are going to find all of our information for the optional method of load calculation here in article 220.80. And it's not just going to be .80, but it's going to be 82, 83, and so on. So the 80s. First off, it is good to note that a question will always mention if it is going to be using the optional method. If it does not mention that it is going to use the optional method, that means it is going to use the standard method. The standard method is what I taught in my residential load calculation videos. If you aren't familiar with that, be sure to check out that video before this, as that video will prepare you and get you familiar for everything. And as you see, this video will be a lot shorter, but the name says it all. This is the optional method, so this is not the usual method, and the other method is the standard method, so it is more standard. However, you might have a question on this, so it is good to know this. And like the standard method video, we're going to find all the information here in the codebook. So make sure you follow along, and you can highlight and underline things. This is okay if you're going to bring your book even to a test or exam. You cannot actually write written notes, so make sure you underline and highlight the important notes in here so you can flip open your book when you're on a test or exam and you can make sure that everything is correct. So remember that Article 220 in itself is load calculations. Okay, we're going to look at Article 220.82 here, dwelling units. Of course, all of this is important, but I'm going to talk about the main highlights that we need to know to solve our questions and to come up with the correct answer. We see B, general loads. And I'm just going to put things in my own words here. So when calculating the general load, the first 10 kilovolt amps is going to be rated at 100%, and then the remainder is going to be rated at 40%. Okay, so as you can see, that's pretty straightforward. We're going to get into that in a second here with an actual question, an example. But let's actually talk about the nuances of this optional method, the things that are similar to the standard method, and the things that are slightly different, and it is very simple. Okay, so first off, in 220.82b under 1, we see we're still using the 3 volt amperes per square foot for our general lighting and general use receptacle loads. And then if you look at 2, we again have the 1500 volt amperes for the 2 small appliance branch circuits and the 1 laundry circuit. Okay, so we still have the additional 4500 added to the general lighting circuit. We still have the 3 volt amps, so we're used to doing all this. We know we have a different demand factor, so we're still going to get our square footage of the house, multiply it by 3 volt amps, and then add that 4500 minimum every single time. As I went over in the standard method, the 4500 is a minimum because that is when they don't mention anything. You always have 2 small appliance branch circuits minimum, and you always have 1 laundry circuit. You can have more, and as the codebook states, each one of those additional circuits will be rated at 1500 volt amps each. I go over this a lot more in depth in that residential load calculation video. Okay, so I'm gonna start writing things down now. Okay, first thing that we know is we still are working with 3 volt amps per square foot plus the 4500 minimum for the 2 small appliance branch circuits plus laundry. Okay, still in 220.82b, we see under 3 it says the nameplate rating of the following, and it's basically saying all appliances that are going to be permanently installed in place. So as we know, those are appliances that the homeowner, builder, or the question is actually going to tell us. Okay, so if they say we have a microwave, we have a water heater, we have a dryer, we have a range, wall-mounted oven, okay, all these things that are normally separately in their own categories for the standard method, which are all actually just appliances, are all going to be in one category. So we're just going to get all the appliances and basically we're just going to add them all together. Okay, the volt amps or watts, we're going to be using these interchangeably. So if we have one appliance with volt amps and one appliance with watts and we want to add those together, we're just going to add those together. And this is in terms of the load calculations, because as you might know, watts is generally used when you know the power factor of what you're using. And when you don't know the power factor, that's when you use kilovolt amps. Okay, so we're not thinking about power factor here for load calculations, and we're going to be adding all of our appliances together. Again, it's really good to read what it says under 3 there. It says the nameplate rating of the following. Okay, so we're going to get the nameplate of all of these appliances. That means there's no demand factor. We're not going off the demand factor like we're used to. We're taking the numbers that we're told and we're working with those, aka the nameplate. Because in a real life scenario, you might not be told these numbers, you might be actually reading the nameplate, or someone else might be reading the nameplate. Okay, but then after we get the nameplate of all of the appliances, we're going to add that demand factor that we talked about a little earlier. This will be explained in the practice question, so make sure you take a note of that, okay, because this is where the demand factor happens. It's after you know your square foot of your house, you times it by your 3 volt amps, and then you add your 4,500 minimum for the 2 small appliance branch circuits plus laundry. After you add all of that with your appliances, then you do the demand factor. Okay, so really remember that, because there's still a step after this, as you see step 3. And that is heat and AC. You're going to pick the bigger one, just like you're used to. But let's look here at 220.82C, heating and air conditioning. Okay, you're going to want to read 1 through 6, specifically number 4 and 5. You see number 4 says 65% of the nameplate rating if you have less than 4 separately controlled electric space heating units. Then number 5 says 40% of the nameplate rating if you have 4 or more separately controlled electric space heating equipments. Okay, and it's mostly 100% other than that, but you want to read through all of it just to get familiar with it and highlight certain things to help you. Okay, and again, we're picking the bigger ones. So let's say we had an 8 kilowatt heating system and we had a 10 kilowatt AC system. In that circumstance, we're going to pick the AC, and then we're going to add everything as we see step 4. Okay, and this is a little different here because we already have a demand factor after step 2, and then we're adding additionally the nameplate rating of the bigger of heat or AC. Okay, and this does not get a demand factor. This is fully rated. And everything is fully rated until you have the demand factor. Okay, so let's go over these steps. You have number 1, you have your square footage of your house. You're going to times it by 3. Okay, 3 volt amps per square foot. Then you're going to add your 4,500 minimum for your 2 small appliance branch circuits and laundry. Make sure to pay attention if they have more than this minimum, because it's 1,500 per each. That's how we got the 4,500. Then step 2, we get the nameplate rating of all appliances. When they say all appliances in the optional method, we mean all the appliances we'd normally think about in the standard method. So a homeowner or builder is doing a walkthrough in a house, and they tell you we have a garbage disposal, we have a dishwasher, we have a water heater, the usual appliances that you'd think of. But then you also have your dryer and your range in here with all appliances. And normally we're going to separate those with certain demand factors. But here in the optional method, we're not going to have demand factors for the dryer and range. We're going to take the nameplate rating and we're going to add those to all appliances. We're going to add everything together. But then after that, we have the demand factor when we add step 1 and 2 together. Then we have step 3. We pick the bigger of heat and AC and we add that to the number that we already took from the demand factor to the bigger of the heat and the AC. Okay, so it really is simple, but it's a little different that you have the demand factor than heat and AC. Okay, so if we have a 1,600 square foot dwelling, the first thing we're going to do is we're going to get our square feet that we have, and we're going to multiply that by our 3 volt amps, and we know that's going to give us a total volt amperage. 1,600 times 3 is 4,800. Then we're going to take our 4,800, and we're not told anything about anything else, but we know for a general lighting load that we're always going to add the 4,500, which is for those 2 small appliance branch circuits and the 1 laundry circuit. We're going to add these 2 together, and we get 9,300 as our answer there. And remember, there's going to be our no usual demand factor. So we're used to doing the minus 3,000, all that for the standard method. But for this, we're just going to take this number, and this is going to be our total number that we're going to add for our load calculation for the general lighting load portion. Okay, next we're going to be looking at some appliances here. And we're going to be answering how many volt amps using the optional method with a single family dwelling. We see 2 water heaters, water heater 1 and 2, and then a garbage disposal and a dishwasher. Again, for the water heaters, they may say something like, we have a main water heater for the dwelling, and then we have a secondary backup water heater, or something of those terms. or we have a water heater in the additional blah 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 room. We're just going to add everything together with no demand factors. So we're going to get 42,000 plus 3,500 plus 1,000 plus 1,100. We're going to get 9,800. As you can see, the first three are watts. The last one's volt amps. We're not going to be looking at it any differently. We're just going to add them all together. Of course, like I mentioned, the appliances in this circumstance also include the range and the dryer. Okay, because normally those are counted separately with their own demand factors. In this case, it would actually be added to this. Okay, so let's say we're moving on from that same question. We have the 9,800 volt amps or watts. I'll just call it watts in this case, and I'll circle it right here. And let's say now we have an additional dryer, and this dryer is at 4,800 watts. Again, it's the same question, so we're doing the optional method, and we have a single family dwelling. Well, in this case, we're just going to get our 4,800, and we're just going to add it to our 9,800, because there's no demand factors. As you know, usually we get the nameplate in the standard method, and we compare it to the 5,000 minimum. In this case, we get the nameplate rating, and we add that. Because as we remember, the rules was get all the nameplate ratings of all the appliances, add them all together. Okay, and the demand factor is one demand factor at the very end. That's the only demand factor. Okay, so just keep reminding yourself that there's no demand factor. And so let's get that 9,800 and add this 4,800 to it. Because as we know, we got this from our appliances, and now we have our dryer volt amps or watts, and we're going to add this number to it as well. Again, we're going to get a total of 14,600 watts for our appliances so far. Okay, now again, we're going to keep thinking like we're moving on from that same question. We have the 14,600 watts from the dryer and the appliances that we're told they're all appliances in the optional method. Okay, so now let's say that we have a range, and this range is an additional 15 kilowatts. Okay, all we're going to do is get our nameplate rating, what they're telling us, and we're going to add it to our appliances. Okay, so let's go over one more time. Our appliances are basically every single appliance that you usually would have, your fixed appliances in other words, and then including also your range and your dryer, which are normally separate. Okay, so we have our range, 15 kilowatts. We're just going to add it all together. As we know, kilowatt is 1,000 watts. So we have 15,000 watts. Now we have the answer, 29,600 watts for our appliances that we were told, which include the appliances, the dryer, and the range. Okay, so that's covering the appliance section, which again is the appliances we already know, plus the dryer and range. And now we have 29,600 watts for that total number. Of course, from there we would also be adding the general lighting load number. Okay, so now moving on, and if you noticed, we didn't talk about heating and AC, and that is because we get the demand factor of our general lighting load plus our appliances, and then we get our demand factor. After that, then we add the heat or AC, which one is bigger, to that new reduced volt amps. Okay, so just a refresher, we're in Article 220.82 dwelling units, B, where it says the first 10 kilovolt amps is at 100% and the remaining volt amps is at 40%. Okay, so we're thinking about a scenario where this is already solved for us. We have the general lighting load, which of course is the square footage of the house times the 3 volt amps plus the 4,500 minimum, and we have that added to all the appliances. Okay, so after that, we get 32,800 volt amps. Okay, so now we apply the demand factors, and we will get into a question to where we actually have to solve everything ourselves. So similarly to the standard method, we have the demand factor where we're taking a certain percent out, and we have the first 10 kilovolt amps. So we're going to subtract 10,000 from our total, okay? And what we're going to think about is putting that aside. Okay, so we're going to put our 10,000 aside, and of course that is going to be at 100%. Okay, so we're putting the 10,000 aside for now, and we're now left with 22,800. That's our remainder, and as we know, our remainder is going to be at 40%. Now we're just going to multiply this by 0.4. We're going to get 9,120, of course, volt amps. We're going to add these both together. That's going to give us 19,120 volt amps, now using that demand factor. Okay, now that we have this total number, now we would take this and add this to our heating or AC, whichever one of those is bigger. Okay, now to get into an actual question, we want to know the total volt amps when we're looking at a 1,600 square foot home using the optional method. I'm going to get into the numbers in a second, but I really want to just talk about how I set up the page real quick. I still have the appliances like I would do in the standard method, and then HARD. You don't have to do it this way, but for me, this is how I don't leave anything out. I know this is everything I need for a load calculation in a house, and then I know with the optional method, I'm just going to organize things a little differently. So I know that I'm going to have all my appliances as one number. Therefore, I'm going to have a placeholder here, all appliances, where I can put a total number of all of my appliances. We know all of the appliances include the appliances we normally know and the range in the dryer. The other two things that we add afterwards, after the appliances in general lighting, is the heat and the AC. Therefore, I could circle it on my paper, and I'd also give it its own little placeholder here, heat/AC, where again I can put a total number there, whichever one of these two is bigger. That way I know that I'm going to add these two together. These are the two numbers that I'm working. Of course, we know the all appliances has a demand factor, so I could always write that in the beginning, some sort of note. This has a demand factor. This doesn't have a demand factor. Okay, so we already see that from the beginning. Okay, so now we have all the numbers written out. Okay, now before I add up all my appliances, I know that I'm also going to have my total of my general lighting load. So I guess technically here I should put the general lighting load plus all appliances with the demand factor. Okay, so let's get into that. Okay, so 1,600 times 3 is 4,800 plus the 4,500 minimum. And we're going to get our 9,300. And remember always to label it either volt amps or watts. That's going to be our number for our general lighting load. Then we're just going to add that to all of the appliances that we have. Okay, so since we circled heat and AC, it's basically everything that we're looking at here. Of course, besides the heat and the AC. Okay, so we're going to take that 9,300 and then we're going to add everything else. And I just like to go from the top to the bottom. So we're going to have 900 plus 1,100 plus 3,500 plus 11,000 plus 4,800. We're going to add all that together and we're going to get 30,600. Okay, but remember we have the demand factors where we have the first 10 kilovolt amps at 100%. So we're first going to get rid of 10,000. Okay, so it might look a little messy, but we're doing this all right now, so we're going to remember it. So we're going to put 10,000 to the side. That's going to be at the 100%. I always just like to label it so then I can see, oh yeah, that's at the 100%. Now after subtracting 10,000, I'm going to have 20,600 left over from the original 30,600. But of course that's at 40%, so we're going to multiply that by 0.4. We're going to get the number 8,240. Okay, now we're just going to add our 10,000 and our 8,240 together. And that will give us our general lighting load plus all of the appliances with the demand factor, and we'll have this number figured out. So we could probably do 10,000 plus 8,240 in our head. And we have 18,240, always labeled it. We have watts. Okay, now what we do after we figure out our general lighting load plus all appliances, we do the demand factor and we get that total number, is we just pick the bigger of the heat or the AC and we add that to our now reduced number with that demand factor. Okay, so we're going to see how to do this. We have the heat and the AC. The heat's at 10 kilowatts and the AC is at 18 amps at 240 volts. We use Ohm's law. We get 4,320 watts. So obviously we're not going to be using the AC. We will be using the heat and we're going to be using the 10 kilowatts. Okay, so in other words, we have 10,000 watts. And that is going to be our heat/AC because we didn't use the AC, so we're just using the heat. We're going to add both of these together. Okay, I'm kind of running out of some room here, so I'm just going to give myself some room here. And we get the answer 28,240 watts as the final answer. So using the optional method, we figured out the total volt amps for this 1600 square foot home using the optional method with the following appliances and the heating and AC. If you have any questions, leave those in the comments below. If you got use out of this video and you enjoyed it, be sure to give it a thumbs up. And if you want to see more videos like this, subscribe because there will be a lot more coming around the near future. Until next time, take care. Goodbye.